In this video, we will go over a working example of classification using a feed-forward neural network. For the sake of this example, we will start with a pre-trained neural network and will be using hand-picked features. That means that the features are hand-labeled. We want to find out if the phrase, "I am happy," has positive, negative, or neutral sentiment to our network. Our network has a set of handcrafted features, which are word count, the number of words in the text, the number of positive lexicon words like happy or good, and the count of the word no. So for example, in a sentence like, "I am happy," the feature vector would be the following. There are 3 words in the sentence, so the word count would be 3. There is 1 positive lexicon word, happy, so the number of positive lexicon words would be 1. There are no instances of the word no, so the count of no would be 0. Using this information, we can plug our feature vector into our neural network. It's important to notice that this neural network has an output layer with 3 neurons. When a network has an output layer of more than 1 neuron, it usually means we are doing something called multi-class classification. Multi-class classification can perform classification of more than 2 labels. For example, instead of just positive and negative, multi-class classification could also classify for a neutral class as well. Each activation function in the output layer for a multi-class classification network would be softmax. If we wanted to stick to binary classification, just positive or negative sentiment, we would have only 1 neuron in our output layer, and the activation function would be sigmoid. For this example, let's say we want to determine if the output is positive, negative, or neutral, so we will have 3 neurons in the output layer and we will use softmax for the calculation. Since the neural network has already been trained, we have values for our bias vector and weights matrix. Our neural network uses sigmoid as the activation for every hidden node, and softmax for the output layer. Given this information, let's calculate the output vector. We first want to calculate the output of the hidden layer, which is the sigmoid of the weights matrix multiplied with the feature vector x plus the bias. Let's start by matrix multiplying the weights matrix and the feature vector. This gives us a vector of 1, 0.5, and 2.5. Now we want to add the bias, which gives us a vector of 2.0, 1.0, and 2.0. Now we'll want to apply the sigmoid function. As a refresher, the sigmoid function is 1 over 1 plus e to the negative z. In this case, z is our vector that we calculated earlier, which gives us 0.88, 0.73, and 0.88. Let's matrix multiply u and h. U is another pre-trained matrix, and h is the vector we calculated earlier. Doing the matrix multiplication, we get UH is negative 0.82, negative 0.23, and negative 0.52, which we would plug into softmax. The output of the entire neural network is the vector 0.24, 0.43, and 0.32, which is the probability distribution between the classes. These videos were inspired by Josh Starmer at StatQuest. Be sure to check them out.